Okay, today we're going to be talking about similar polygons. It starts on page 101 of your notes, which looks like this. So go ahead and turn there. So if you want to number your page, here's 101, 102, 103, and 104. Don't worry about your table of contents. We'll fill that out on Monday. Okay, so in Math 2 you talked about congruence, which was when two triangles or quadrilaterals or whatever were exactly the same. So what we're talking about is similarity. So in order for two polygons to be similar, they must first be the same shape, and then their angles must be congruent. And their sides must be, their sides must be proportional. So sides must be congruent, angles must be congruent, and sides must be proportional. So if we look over here at number 1, it says, are the rectangles similar? Well, hopefully we know that all rectangles have 4 90-degree angles, so we know our angles are congruent. So what we need to know is, are our sides proportional? So the easiest way to do this is to match up the similar sides. So on this one, it's easiest to go small side to small side, big side to big side. There's a bunch of different ways that you can set up these proportions, and here's just one of them. So on our first rectangle, 18 is our smallest side, and on our second rectangle, it's 25. And we want to know, does that equal 36 over 45? So if you type this in your calculator, 18 over 25 gives you 0.72. And then 36 over 45 is 0.8. So we can see that those two things are not equal. So then these are not similar. Okay. So let's look over here at number 2. So we want to know, are the triangles similar? Well, first we look at our angles. We've got two 90-degree angles, 260, 230. So our angles are congruent. So now we check our sides. Again, a bunch of different ways you can set up these proportions. But I'm going to look at smallest on each triangle. So my smallest on this bigger triangle is 16. So I'm going to go 16 over, smallest on the right is 8. And I want to know, does that equal 30 over 30 matches with 15? And then our last one's 34 over 17. So you can type all of these in your calculator and make sure that they are all equal. And hopefully you see that all of them equal 2. So then these are similar. Now, even if one of them was like 1.5 or something, then it would be no. So our next problem, we are given that the quadrilaterals are similar, and so we want to find x. So we try to match them up. Again, we can see that x is going to match with 15. So we can say x over 15. And then the only other side that we know over here on the left is 35. And hopefully you see that 35 matches with 25. And again, there's a bunch of different ways you could do this. You could say x over 35 and 15 over 25. As long as you match, like on the top we've got the first quadrilateral and on the bottom we've got the second quadrilateral. So then to solve this, you just cross multiply. So x times 25 is 25x. And then 35 times 15, gives us 525. And then all we do to solve for x is divide by 25. And we get 21. Okay, so same thing for number 4. We're given that the triangles are similar and we want to find x and y. So I can see that x matches with the 28. So I can say x over 28. And then the only side we know is 54, and that matches with 42. Again, we cross multiply, so 42x equals 54 times 28 gives us 1512. And if we divide by 42, you get 36. And then we also want to find y, so we see that y matches with the 35. And then we can use that same 54 over 42. Again, we cross multiply. And 54 times 35 is 1890. Now our last step, divide by 42, and y equals 45. Now again, if you set up a different fraction and got the same answer, that's okay. There's multiple ways to do each of these problems. Okay, so just like in Math 2, you talked about triangle congruence, and there were things like side, 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 angle, side, and things that helped you prove that they were congruent. So the same thing happens in Math 3 when we're talking about similarity. So similar triangles are postulates that help us decide if triangles are similar. So our first one is angle-angle. So the angle-angle postulate says that if two angles of one triangle are congruent, to two triangles in another triangle, then the triangles are similar. So if we only know two angles, we know every triangle adds up to 180, so if you know two angles, you automatically know that the third angle is also congruent. But here we don't know anything about the sides, so we don't know if the triangles are congruent, but we can assume that they're similar, so they're proportional. So if we look at this first triangle here, it tells me that T and G are congruent because they're both 61. And then hopefully we remember that these here in the middle are congruent because they're vertical angles. So since we have two sets of congruent angles, we can assume that these triangles are similar. Now one thing that you might want to or might have to write is a similarity statement. So to do that, we're going to say triangle TSH. And then the sign for similarity is just a squiggly. And then to write the other triangle, you match the angles. So T matches with G, S matches with F, and H matches with itself. And then we can say they're similar by angle, angle. And then same over here on this next one, it tells me that T and J are congruent and U and K are congruent. So we can assume that they're similar, so if we wanted a similarity statement, we could say UVT is similar to U matches K, V matches L, and T matches J by angle. So our next postulate is the side. So it says if corresponding, if corresponding sides of two triangles are proportional, then the triangles are similar. So our sides don't have to be congruent, they have to be proportional. So to decide this, we just want to set up some proportions like we did at the beginning. So we can match 48 and 8. We want to know, does that equal 72 over 12? And then does that equal 84 over 14? And again, to determine that, you just type them all in your calculator. And hopefully you see that all of them equal 6. So then they are similar. So we can write our similarity statement. So triangle ABC is similar to triangle A matches H, G and B, and C and F by side. So even though we don't know anything about the angles, we can assume they're similar because all of our sides are proportional. Now this next triangle is a little bit trickier because we have the big triangle FDE and then we've got the small angle triangle FSR. So before we can see if they're similar, we have to find this missing side of FR. So if we know the whole thing is 143 and RE is 91, we can just subtract. And so our FR is 52. Okay. So again, we can set up our little proportions. So 52 matches 143. Oh, we also have to find FS. So 88 minus 56 is 32 here. And then that 32 matches 88. And then our last ones are the bases, so 44 and 121. So again, you just type all those in your calculator. And see that they all give you the same decimal. So they're similar. So we can say triangle FDE is similar to triangle FSR by side. Okay. And then our last one here is angle side. So what it says is that if two sides are proportional and the angle between the corresponding sides are congruent, then the triangles are similar. So we've got two proportional sides, the angle between is congruent, then we can assume that they're similar. So if we look at the first one, we've got C and T are congruent, and they're between our two sides, so we're good to go there. So we need to know, are the sides proportional? So we can say 27 matches with 9, and 30 matches with 10. And then if we divide, we get 3 both times. So 3 equals 3. So they are proportional. So then we can say triangle ECD is similar to triangle UTV by side, angle, side. So it doesn't work if the angles are not between the sides. Like if we knew U and D, we couldn't assume side, angle, side because the angle is not between the two sides. Okay. So our next example over here, we don't know anything about the angles, but we have vertical angles, and vertical angles are congruent, and they are between our two sides. So if we match them up on here, you would automatically probably match up 14 and 28, but we actually match up 28 and 8, and then 49 and 14. And that's kind of where that biggest and smallest thing helps you out. So if we divide these, we get 3.5 each time. So then we can assume they're similar by side, angle, side. So triangle MLV is similar to triangle TUV by side, angle, side. Okay, so we've learned 3 postulates. We have angle, angle, side, 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 and side, angle, side. So now we want to know, are these triangles similar? If so, how do we know? So for number 1, we have the big triangle, KLM, and then the smaller one, KBC. We know that this angle at K is in both triangles, so therefore it's congruent. But that's the only angle that we know, so we can't assume angle, angle. We only know 2 of the 3 sides, so we can't say it's side, side, side. So our only chance would be side, angle, side. So we've already got the congruent angle part. So now let's see if our sides are proportional. So first we have to figure out the big side, KM. So if we add 25 and 107, you get 132. And then we see if they're proportional. So 16 matches the 88. And then 25 and 132. And then if we type those in our calculator, our decimals are really, really close, but they're not exactly the same. So 0.18 and then 0.189. So we cannot assume that these are similar. So they have to be exactly the same proportion. So again, looking at number 2, if we look at our angles, we only know one set of congruent angles. So we can't assume angle, angle. And again, we only know 2 sides, so we don't know if it's side, side, side. So again, our only chance is side, angle, side. So we can set up our proportions. And again, you can set them up a bunch of different ways. So I'm going to say that the 9 matches with the 21, and then the 18 matches with the 42. And then if you type those in your calculator, you see you get the same decimal, about 0.43 or so. So then we can assume that these are similar by side, angle, side. And then our similarity statement, triangle WUV, is similar to triangle HE. Oh, sorry, F, not E, G. And again, to write that, you match your angles. So W matches H, F matches U, and G matches V. Okay, and then the last thing we want to do here is solve some examples. So it tells me, given that the triangles are similar, we want to solve for x and find the missing side. So since they're similar, again, we know that they're not congruent, but that they're proportional. So on this one, we have to set up a proportion. Again, a bunch of different ways you can do this. I'm going to say that my 5x plus 11 matches the 18. And then 88 matches 24. And these are a little bit tougher, but just like the last ones, we want to cross multiply. So we're going to have 24 times 5x plus 11 equals, and then 88 times 18 is 1584. And then if you want to distribute that 24, you can. But since it's being multiplied by everything, the easier way to do it is divide by 24 from the start. So then we get 5x plus 11 equals 66. And then I know you guys know how to solve that. Just subtract 11 and divide by 5, and you get x equals 11. But on these, it's tricky because they might not even ask you for x. They might ask you for the side. So you always want to check and see. And this problem wants to know VU. So to find that, we have to plug in that 11. So VU equals 5 times 11 plus 11. And so that is 66. So really check and make sure you know what they're asking you for on these problems. Okay, so this next one we know a whole bunch of different stuff. The one we really care about, of course, is the one with the x. So we can say negative 4 plus 4x matches with 64. And then it doesn't matter if you use the bases or this other side over here. You're still going to get the same answer. So I'm going to say 36 over 96. But again, you could do 27 over 72 and have the same answer. So we cross multiply. And 36 times 64 is 2304. I'm running out of room here. Again, easiest thing to do is divide by that 96. You can also distribute it and you'll get the same answer. Your numbers will just be a little bit bigger, but you'll still be getting the same thing. So when we divide, we get 24. Again, I know you guys know how to solve it, so add your 4. So 4x equals 28. And then divide by x, or divide by 4, and x is 7. But again, our problem wants to know JU, so we have to plug that back in. So negative 4 plus 4 times 7. And then that gives us 24. Okay, and that's all I have for you for notes today. So I would like for you to do page 103 and 104, all of the problems. It's only 15, so it shouldn't take you that long. When you finish, work on your recap. Remember, that is due on Monday.